So hello friends, so far what we have learned, based on that we can reach to these two interesting statement. So here I am writing type of decimal expansion. Okay, type of decimal expansion. Here type of number. Okay, so if the type of expansion is terminating, then the type of number will be rational number. If it is non-terminating plus recurring, then also it will be rational number. In these two cases it will be rational number. And if any number is rational number, then its decimal expansion will be either the first one, its decimal expansion will be either this one or that one. Okay, so if this is true, then this is also true. If this is true, then this is also true. Okay, so this is first statement. Now let us go to second one. If the decimal expansion of any number is non-terminating and non-recurring, then type of number is irrational number. So if any number is irrational number, then its decimal expansion has to be this. It has to be non-terminating, non-recurring. Only one option here. Here you have two options, but here you have only one option. Okay, these two at the same time, it has to satisfy these two conditions. It has to be non-terminating and also non-recurring. Okay, so, and here we are not proving anything, we are just stating this based on some previous examples. Okay, so let us give some examples of, let me clear it. Let us give some examples of, let me resize it. 4,000. Okay, so let us give some example of irrational numbers. 0.01, 001, 0001, 00001, ... This is a non-terminating. This expansion is non-terminating because it is not terminating or stopping anywhere, and also this is non-recurring because same block is not repeating. Here 01, then 001, so same block is not repeating. Okay, so this is an example of irrational number. Then there are many other examples like root 2. And what is its decimal expansion? Its decimal expansion will be like 1.4142. You should not remember entire expansion. You cannot actually, because it will go on like that up to infinity. So you can just remember that it is close to, root 2 is close to 1.4. Okay, so pi is also an irrational number, and its value is like 3.1 4 on 5, 9, 2, and so on. You should remember only 3.141, that is sufficient, 3.141 pi. Or there is another way of remembering a number that is very close to pi, that is 22/7. Okay, so if you do it, you will get like 3.14 is correct. Up to 2 decimal point, maybe this is correct. Okay, so there are some methods of finding these expansions, but here we are not going to explain those methods. Okay, rather in this place we are going to share with you some history, like in Sulba Sutras, that was written around 800 BC or something like that. Indian mathematicians actually found that root 2 is close to 1.4 on 4 to 1 5, so they were quite close, like 4 on 4 to 1, 4 on 4 2, up to 4 digits they were correct. And the formula they used to find this is 1 plus 1/3 plus 1/4 into 1/3 plus minus 1/34 into 1/4 into 1/3. And where they have got this equation from, this expression from, is not known to me. If you read maybe higher study, then you will find how they have exactly found this formula. Okay, and this is not part of your syllabus, maybe it will be heavy for you, so they have not given it. So you maintain your high interest in mathematics, and one day you may find how they have got this formula. Okay, so pi is another irrational number, and it is known it was known to ancient Indians, Persians, Greeks, and so on. And many people have actually assigned this value of pi like 3. But for the first time Archimedes actually around 450 BC or 60 BC, like that, Archimedes for the first time proved that pi is greater than 3.14085, and pi is less than 3.14287. You don't have to remember this thing, but he has proved that pi has to lie between these two numbers. That means pi must have these digits, means these digits are correct, like 3.14 is correct, then it is less than 2, greater than 0, so here it must be 1. Okay, then we cannot say what will happen, because if this is 1, then it can happen anything, like if it has to be between this and that. So if you see actual expansion, after 1 there is 5, so he was correct. He correctly predicted that its exact digits after decimal point, he could predict up to 3 digits. Okay, and he was able to say that pi must lie between these two numbers. Okay, so these are stories. Now let us go to examples. Okay, forget everything, that means just put all these things in your subconscious mind, and you put your consciousness in the examples now. So let us go to your textbook. Full focus on this example. Okay, and previous things what I have taught, that will actually be in your subconscious mind, and you in your memory you will remember those things, don't worry. Okay, you will see again and you will remember those things. So example 10, find an irrational number between 1 by 7 and 2 by 7. What will you do? Let us do it. Okay, even though they have done here, we should do by ourselves. 1 by 7 and 2 by 7. Okay, so 1 by 7 and 2 by 7, 2 by 7, you have to find an irrational number between these two numbers. So what you will do, you will expand this into its decimal expansion, and I think I have already done it in the previous video. So let me just write what it will be. It will be 142857, 142857. so 142 0.142857, and this will repeat again and again. Okay, this will be the value of 1 by 7, and what will be the value of 2 by 7? Okay, if you use your common sense, just you multiply this by 2, you will get the decimal value of this. So it will be like 0.24. we should multiply from that side to this side. Okay, so it will be like you multiply this by 2, so it will be 4, 14, 4. So then again 5 into 2, that means 10, then 11, then multiply by 2, 16, so 17, 7, and you will have 1. So multiply by 2 to 4, then it will be 5, then 2, 4, 8. You just multiply this by 2 and then 2. Okay, so this means this, and this will repeat again and again. Okay, so if you have to write a number, an irrational number between these two numbers, you can just write like 0.15 dot dot dot, because 0.15 is greater than, oh my god, we cannot repeat it because we are finding irrational numbers, isn't it? So we cannot repeat it. So what we have to do, so okay, so we have to use some trick like 0.150, then 1500, then 15000. So it is not recurring now. Okay, it is non-terminating and non-recurring. So this is an irrational number between these two numbers. Then what else? 0.14, let us say 30. Okay, 14300, 14300. This is also another possibility, because it was 142, I have written 3, so this number is greater than this, but it must be less than that, because it was 2 just after the decimal point. So this is another possibility. So what else? You can write 0.14, let us say 31. Can we write like that? 143 double on, 143 triple on, 143 4 on. Can we write like that? Yes, because this number is greater than this number, because here we have written 3, and whatever we write after that, it will be greater than this, but it must be less than that. And it is non-recurring also, because for the first time we have written on, then double on, then triple on, and then 4 ons. Okay, so this is why it will actually it is an irrational number, but it will go on forever, and it is non-terminating also. Okay, so this example is done. So what we have done this, let me actually clear this one once again. So 0.14 we have written 0.14, then we have written 3. Okay, then 1, then we are repeating again, on 4 3, then double on 4 3, then triple on, then on 4 3, then 4 on, then again there will be on 4 3, then 5 ons, okay, 5 ons, and it will go on like that. So this is another irrational number. Now let us do some exercise. Okay, this is done, this example is done. Now let us do some exercise. Exercise number 1, write the following in decimal form and say what kind of decimal expansion each has. So you have to expand this. This will be just like 0.36, you know this, okay, and you can do all these divisions, isn't it? So find the divisions, write whether it is terminating or not. If it is terminating, whether it is recurring or not. All of these will be recurring, isn't it? Either terminating or non-terminating recurring, because they are written like p by q. So this is done. You can do this. You do it by yourself. You should have patience and you should do all the 6. Okay, don't try to be over smart and skip anything. Just do it. It is easy, so you have to do it little faster. But even if it is easy, never ever skip any mathematical problems. This is my suggestion. Okay, if it is easy, it will not take much time. It will take maybe 2-3 minutes, isn't it? So why will you skip? It is easier, then automatically you will require less time. You don't have to skip. Okay, so you know that 1 by 7 is this. Can you predict what the decimal expansion 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6? What you have to do, you just have to multiply this by 2. You start to multiply by 2, then 3, then 4, then 5. Now you may think that what they have written here, why I have to actually think about reminders, what they have written here, isn't it? It seems quite interesting why they have written this, because actually what they are wanting to say is, if you multiply by this this number by 2, you will see the remainder will also be twice, isn't it? And the quotient also will be twice. Then again you will get remainder, and that will be again twice, means actually double than what remainder you will get in each step. Okay, in similar step you will get remainder, double remainder in this case, and triple or 3 times of the remainder that you will get in this case, and quotient also will be 3 times, okay, in every step. So if you didn't understand what I am saying, you just do it by yourself, expand these things by yourself first, and try to see whether it is coming like that or not, and then again listen to me what I am saying. Okay, so this is also done. Now express the following in the form of p by q, where p and q are integers and q not equal to 0. So 0.6, let us do 0.6 first. So 0.6 bar means it is 0.666666666 like that. It will go on like that. So they have asked you to represent this like p by q. So we have done some example. Again let me do it. 0.666666666 dot dot dot. So you multiply this by 10, so you get 6.66666. okay, you can write right hand side like 6 plus 0.66666. so 10x is like that. So you can write 6 plus, this is again x, isn't it? Same expression. So this is again x. So you get 9x equal to 6, x equal to 6 by 9, that means 2 by 3. Okay, if you don't believe that this process is correct, then again you expand this into its decimal expansion, you will get, certainly you will get this. Okay, so this is done. So first one is done. Now which one you want to do? This one. You have to multiply by 10. Okay, sorry, you have to multiply by 100. If you multiply by 100, what will you get? Let us try to do it. It was 0.047 and bar. So it means it is actually 0.47777 dot 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 like that. If we take this as x, now we multiply this by how much? 100. So this is 100x equal to, actually we can do this like we can multiply by 10 also, and this will be done. It can be done in many ways, but let us multiply this by 10. I think I can do it even if I multiply by 100 also. So it will be 4.77777, but we need this expression again, so we write it like 4.3 plus 0.4777 dot dot dot, isn't it? So 10x is that. So this is again x, we have got this expression. So 10x equal to 4.3 plus x. So 9x equal to 4.3 means 43 by 10. So x is 43 by 10 into 9 is 90. Answer. So this is also done. This is very easy, and you can do this. I think you should do it by yourself. If you can't do it, please write in the comment section, I'll solve it. I think it is very easy. Now let us go to question number 4. Question number 4, just multiply by 10 and you will see something surprising. You will see that its p by q form is nothing but 1. Should I do it? Okay, let me do it because this is little different. So 0.999999. Are you bored by this color? Let me change the color so that your boredom is reduced. So if we write this as x equal to this, 10x means 9.99999999999. So you can go up to infinity, and you can write the right side like 9 plus 0.9999999, and this is 10x. So this is x again, same expression. So 10x equal to 9 plus x. So 9x equal to 9. So x equal to 9 by 9, that means 1. So this is 1 means 1 by 1. So this is again p by q form, and it is surprising that x is 1. Here I have written x is not 1, x is 0.99999, and here we have found in its, if we try to write it in p by q form, it comes to be 1. So what is logic behind this? Are they contradictory? No, they are not contradictory, because this number is actually 1. If you go up to infinity, this number becomes 1. Okay, so because 0.99999 is very close to 1, and as you increase the number 9, more and more 9, it goes to more close to 1, and if you go up to infinity, it becomes just 1. Okay, so this number is nothing but 1, even though it looks different, but it is 1. Okay, so that is also done. So they have actually asked you to discuss about this and whether it makes any sense or not. Yes, it is making sense, I have already told you why it is making sense, because 9 itself, 0.9 is itself is close to 1. Now if you write 9.9, that means it is even closer to 1. 99.999 is even closer to 1. Okay, and if you go like this up to infinity, it becomes 1. Okay, because goes closer and closer and closer to 1, so finally it becomes 1. You can think like that, so it makes sense. What can the maximum number of digits be in the repeating block of digits in the decimal expansion of 1 by 17? Perform the division and check your answer. What they have said, that maximum number of digits in the repeating block of this expansion, it will be less than what? 17. So maximum number can be 16. Okay, the digits in the block of repeating block, the number of digits will be either 16 or less than 16. It will be less than 17, so it can be, its maximum value can be 16. So you just divide it and see how many numbers you get in the block that is repeating. Okay, you can do it. I should not waste time. Already this video is very long, 26 minutes has been passed, so you can do it. Just divide it and see how many digits are repeating. Look at several examples of rational numbers in the form of p by q, where p and q are integers with no common factors other than 1 and having terminating decimal representations. Can you guess what property p and q satisfy? So they are terminating. If you write any number like p by q and you write them in co-prime form, that means there will be no common factors. Like if I write this like 8 by 4, then there is common factors, isn't it? There is common factor. This will be 2 by 1. If you write something like 18 by 12, then there are some cofactors, like 3 is cofactor. So 3, 6 and 4, and then again we can do it like 3 and 2. So this can be written like 3 by 2, isn't it? So this, if we write any number in this form where there will be no cofactors, then if it becomes terminating, if this representation becomes terminating, what is the property of q? Okay, if you do the various examples, just examples, there is no theory to prove it, at least in your level. So if you do some examples, you will see that all those expressions are terminating when the decimal, this q can be represented like 2 to the power something, like 2 to the power 1, that means 2, or 2 to the power 0, that means 1, that means it is actually the integer number. 2 to the power 2 or 2 to the power 3 or 2 to the power x, you can in general say 2 to the power x, where x is any integer. If you can write q like that, then it will be terminating. Or if you can write q like 5 to the power x, where x is integer, then also it will be terminating. Or if you can write q like 2 to the power x and into 5 to the power y, where x and y are some integers. Okay, like for example, let us put in the place of x we can put 2, and in the place of y we can put 3. So this will be like let us write smaller one, write 1. We can write whatever we want. So it will be, this expression will be 4 into 5, that means 20. So if q becomes 20, then it will be terminating. Okay, this will certainly terminate. So what I have said here, okay, if any digit, let me again clear it. If you write any number in p by q form, and if P and Q becomes co-prime, that means there is no common factor between P and Q, then if you see that Q is like 2 to the power some number, 2 to the power some number means 2 to the power 1 means 2 to the power 1 means 4. It can be like 2 to the power 2 means 2 to the power 1 means 2 guys, not 4, it is 2. 2 to the power 2 means 4, 2 to the power 3 means 8. If you see anything like that, or if you see Q equal to 2 to the power some y, where y can be like 1, if y is 1, that means, sorry, I am saying 5 to the power y, 5 to the power 1 means 5, then 5 to the power 2 means 25, 5 to the power 3 means 125, like that. If you see Q is any of these numbers, or Q is any of these numbers, or if you see that Q is like 2 to the power x and into 5 to the power y, where x and y can have any values like 0, 1, 2, 3, whatever. Let us put 2 and 2. So 2 to the power 2 into 5 to the power 2 means 4 into 25, that means 100. If you see any number like that, then it will certainly terminate. Okay, so this is what you see. This is the property of Q. So you can guess that it will be either power of some power of 2, or it will be some power of 5, or it will be some multiple of power of some 2 and power of 5. Okay, this is what you will see. And then question number 7, write 3 numbers whose decimal expansion are non-terminating. Decimal expansion are non-terminating and non-recurring. Root 2, root 3, pi. These numbers are non-terminating and non-recurring. Okay, and you can write that these kind of number also, 2, 5, 3, 1, 2, 5, 3, double on, like that. You write a pattern and dot dot dot, that means it will go like that, but it is not repeating, because here I have written only 1 and here 2 ones, here 1 1 and here 2 ones. Okay, like that. So this is also a non-terminating, non-recurring. Now question number 8, find the different rational numbers between this and this. What will you do? I have shown you already in one example. You just expand this in its decimal expansion, and this also in its decimal expansion, and take some initial numbers, then take other number, third or fourth number in between these two numbers, so and repeat it again and again, and you can do it. And if you cannot do it, please write it in the comment section. I have already done one in your examples. It is already done in your example, isn't it? I have done it earlier. So now classify the following numbers as rational or irrational. This is irrational, this is irrational, because they cannot be just written like, if it was root 4, then we could write like 2 or like that. So this is rational, but these numbers are irrational. This is rational, this is repeating, yes, this is repeating or recurring, so this is rational. Is this repeating? 1 0 1, then 0 0, okay, so this is not repeating, so this is irrational. So exercise 1.3 is also done. So guys, I am just stopping here. This video is already too long. I should not make very long videos, otherwise you guys will not have much patience. So if you like this video, please hit the like button, and also subscribe this channel. Subscribe this channel, because this channel is new channel and I want to cover entire syllabus, and I will answer whatever doubts you have. You write it on the comment, in the comment section. I'll definitely answer your doubts, okay, and I'll solve some high level of problems also at the end of your book. If I cover your entire book, I will try to solve some high levels of mathematical problems for you guys, and I guarantee you, if you can follow me completely, you will become like top in mathematics. I can guarantee you, because I am not leaving anything, I am covering everything, isn't it? So if you do everything, then you will get 100 marks, but you have to practice yourself, isn't it? So do it by yourself. Okay, I am stopping here. I'll see you soon in the next video.